What is effective instance voltage? The effective instance voltage, or the EIV, is the rail-to-rail voltage obtained during rail analysis. It is calculated by processing the voltage waveforms and finding the worst-case effective voltage between the power and ground pins during a specific window. These windows, also known as evaluation windows, are the selected sections of the simulation where the EIV will be evaluated by rail analysis tools like Voltus. The EIV and the evaluation windows are depicted in the figure on the slide. The evaluation window determines what portion of the voltage waveform will be considered when calculating the EIV. There are 4 possible windows to evaluate EIV, like switching, timing, both, or elapse. These terminologies are explained in the given figure. In switching mode, EIV is only selected when the instance is switching, and there is a switching current along with the leakage current. In timing mode, the time interval when the instance can switch is identified by the timing window file or the embedded timing engine. There could be a situation when the switching of the instance happens outside the timing window, if the instances are scheduled to switch near the start or end of the timing window. In this scenario, combining the switching and timing intervals yield the correct results. Hence, the mode both is the default mode for EIV eval window argument within set rail analysis config command. The Elapse mode calculates EIV for the entire rail simulation and not filtered to a specific window. EIV_method within set rail analysis config command allows different methods of computing EIV during rail analysis. It allows you to write out the best, worst, or average effective instance voltage between power and ground nets. The worst average EIV method computes the average instance voltage during each evaluation window, defined by the -EIV eval window parameter, and reports the worst average instance voltage out of all the windows as shown in the given figure. The best and worst evaluation mechanisms give the best and worst drop value respectively inside the window, while the average one gives the average drop for all the windows. The EIV report is generated inside the Reports folder of the Rail State directory and given by worst.iv extension. A sample worst EIV report for VDD-AO-NVSS is shown here. Given an EIV report, how to interpret the different columns in the report header. The various header fields are explained here with an example. Win EIV shows the worst effective instance voltage in switching window. PWR Win EIV gives the instance voltage for power in switching window and is calculated as the difference of the nominal voltage and power voltage drop given in the instance's attribute viewer window. The ground voltage bounce is shown as GND Win EIV. Elapse EIV column gives the worst effective instance voltage across simulation window. The PWR Elapse EIV and GND Elapse EIV fields give the instance voltage for power and ground for simulation window, respectively. Due to resistive power grid or simultaneous switching of close instances, there is reduction in voltage on VDD nets and increase in voltage on VSS nets in the power supply networks. These deviation in voltage compared to the original values is IR drop on VDD nets or ground bounce on VSS nets. The localized drops in the power supply voltage decrease the operating voltage of the chip, potentially causing timing problems and functional failures. The instance voltage is the worst rail-to-rail voltage for each instance, and it can be used to perform IR drop-aware delay calculation and timing analysis.